Okay, so for 5A, you should have the test in front of you, so I'm not going to write the whole problem out, but I'm just going to read it to you. It says a company plans to manufacture a certain product with fixed costs of $50,000, and it will cost $140 to manufacture each unit, and each is going to be sold for $300. Write a function that describes the profit P in terms of units sold X. So this type of problem involves profit and revenue. So here's a couple definitions that you want to know first before we jump into setting up the equations. Your profit is equal to revenue minus the cost. Revenue is how much money you bring in, and you subtract the cost out. That'll give you the profit. So what revenue would be is the amount you're selling the product for, and then times the number of units. So that gives you the total amount that you take in. So with these definitions, we want to come up with some algebraic expressions for each one, and so we can find the profit. So it asks us to write this as a function. So as a function, we want to make sure we use the right notation for that. Let's try and set up these equations. Now, in order to do profit, we have to come up with a revenue and a cost equation. Let's first start with the revenue. So revenue right here, that would be R of X. We're going to use the function notation. That's equal to the price times quantity. We have to see how much each of these are sold for. So we want to make sure we grab the right number here. We're not going to use 140 because it says it costs 140. That's going to be used in our cost equation that we'll write in a minute. So the one we want to use is 300. It says each will be sold for 300. So I'm going to do 300, and then the quantity we're using X to represent the number of units that are sold here. So 300X would be your revenue equation. We also need the cost, and then we're going to subtract those to get the profit. So let's come up with a cost equation. Now for cost, we're told that we have fixed costs of $50,000, and we have, it says it also will cost $140 to manufacture each unit. So if we write out the equation for that, that's going to be 50,000 plus 140x. We have our fixed costs that we're going to have to pay no matter what. That might be for facilities or equipment or something like that. And then there's a variable cost, the 140, that might be cost of materials and labor and things like that. So that's a cost that's going to be incurred for each particular unit. Now that we have these two equations written out, we're ready to do the profit one, which is what they're asking us for. So we're going to write it as P of X. So on these problems, you want to make sure you use the correct letters that they're telling you to use. So if it says profit P, that means we have to use P for profit, and then X represents the number of units. So we want to make sure we use the correct notation that it's asking us to use, the correct letters. Alright, so now we're going to do profit is equal to revenue minus the cost. That's what it would be translated into based on what we have here, based off of the definition. So now what we can do is put in our formulas. We have 300x goes in for revenue, and then we have cost as this bottom one we did. Now what's important about this is you want to make sure you put this all in parentheses, because you're subtracting the entire equation. So this is the most important thing with this problem, is making sure you distribute the negative, because otherwise you may have all that set up correctly, but then you might have a wrong sign. So for this, when we set this up, the negative actually applies to both of these. So we're going to take 300, we got to do minus 140 to get, because we have some like terms there. And so then it's going to be 160x by subtracting that. The negative also applies to the 50,000, so we have minus 50,000. So if you want to do an extra step and multiply through by a negative and then add like terms, that's okay as well. I kind of did both of those together. 300 minus 140, and then negative 50,000, and we have this. This would be the proper function notation. We have P as a function of X. X is the main variable, and so that would be our final answer.